Imagine standing on the surface of the moon and looking back. What you would see is a glowing blue sphere suspended in absolute darkness. Swirling white clouds, vast shimmering oceans catching sunlight across 3/4 of the visible surface. It looks peaceful. It looks almost fragile. It looks like the most beautiful thing in the solar system. But to a planetary scientist, that blue sphere is not a wonder. It is a contradiction. By every physical law governing how planets form, that water should not be there. Earth was built in the hottest zone of a newborn solar system, a region where any water would have been burned away, vaporized, and blasted into deep space billions of years before the first ocean could have formed. We orbit a nuclear furnace. We exist in a zone where moisture has no right to survive. And yet, 1,350,000,000 cubic kilometers of liquid water sits on our surface. It fills trenches 11 kilometers deep. It moves through every living cell on the planet. It shapes every coastline, every canyon, every weather system. Where did it all come from? The answer is one of the most contested, most surprising, and most consequential questions in all of science. And the deeper you go into it, the stranger it gets. This is the full story, from the fire of Earth's birth to the water in your glass right now.
Part 1, the planet that shouldn't be wet. To understand why Earth's oceans are such a puzzle, you need to spend a moment with our neighbors. Look at Mercury, a scorched, airless rock of iron and stone, baking in full sunlight with no protection. Look at Venus, a pressure cooker wrapped in sulfuric acid clouds, where surface temperatures melt lead and any water vaporized into space billions of years ago. Look at Mars, a frozen desert where water exists only as buried ice at the poles, the remnant of a wetter world that died when the planet lost its magnetic field and its atmosphere was stripped away. These are the inner planets, stone and fire, and Earth is one of them. We formed in the same zone, from the same raw materials under the same young sun. The disk of gas and dust that collapsed into our solar system was governed by a simple rule: the closer to the sun, the hotter, and heat is the enemy of water. Astronomers have mapped a boundary in the solar system called the frost line, or snow line. It works exactly as the name suggests. Inside this line, which ran roughly between Mars and Jupiter in the early solar system, temperatures were too high for water to exist as anything but vapor. The dust grains that clumped together to build Mercury, Venus, Earth, and Mars were bone dry, rocky, metallic, moisture-free. Beyond the frost line and the cold outer reaches where Jupiter and Saturn formed, water was abundant. It froze onto dust particles, built up into massive ice deposits, filled the bodies of comets and asteroids in quantities we can barely calculate. By the physics of planetary formation, Earth is on the wrong side of that line. We were assembled from dry inner system dust. We should be as barren as Mars. We should be as arid as Mercury. Instead, we are covered in oceans. Something brought that water here, and figuring out what and how is the problem that has occupied planetary scientists for decades.
Part 2, Earth's violent birth and the collision that reset everything. Before we can ask where the water came from, we need to understand what Earth looked like before it arrived. 4.5 billion years ago, the young Earth was not a planet. It was a construction site. Dust and rock and metal were clumping together under gravity in a process called accretion. Planetesimals, objects the size of mountains and small moons, were constantly colliding, merging, transferring their kinetic energy into heat with every impact. The violence was incomprehensible by any modern scale. The young Earth was not hot. It was molten, a global ocean of magma, glowing white at its surface, radiating enormous heat into the black sky above it. Any water that might have been present in the original rock would have been driven out instantly, boiled into vapor and blown away by the ferocious solar wind of the newborn sun, which was far more active and violent than the relatively stable star we know today. The standard model of early Earth is a completely dry ball of magma. No water, no atmosphere worth speaking of, a sterile, glowing sphere. And then, before it had even finished forming, something hit it. The giant impact hypothesis describes an event approximately 4.5 billion years ago when a Mars-sized body, scientists call it Theia, collided with the proto-Earth. Not a glancing blow, a near-direct impact that partially merged the two objects, releasing energy so immense it remelted the entire planet and ejected trillions of tons of vaporized rock into orbit. That debris eventually coalesced into the moon. For the story of water, this moment matters for one brutal reason. It was a sterilization event. Whatever volatile compounds, whatever traces of moisture the young Earth might have accumulated before the impact were obliterated completely. The heat was so intense it stripped away any early atmosphere. The planet was left spinning, tilting, cooling, and absolutely, completely dry. The clock reset to 0. The empty vessel was ready, but it had nothing to fill it.
Part 3, the Late Heavy Bombardment. About 3.9 billion years ago, the solar system destabilized. Jupiter and Saturn, the two gas giants, were slowly migrating, shifting their orbits in a gravitational dance that sent shockwaves through the entire planetary system. Their combined gravity acted like a slingshot, pulling millions of asteroids and comets from the cold outer system out of their stable orbits and hurling them inward toward the Sun, and directly into the path of Earth. This period is called the Late Heavy Bombardment. For millions of years, Earth was pounded relentlessly by an enormous rain of space debris. Not small meteorites, mountain-sized chunks of rock and ice impacting the surface with the force of nuclear arsenals, over and over without pause. This catastrophe was also, potentially, a delivery service. The water had to come from somewhere beyond the frost line. The question was, what kind of object was carrying it? And for a long time, the most popular answer was the most visually dramatic one: comets. Comets are the frozen debris of the early solar system, ancient bodies made of ice, dust, and rock, formed in the outermost reaches where temperatures are near absolute 0. They contain enormous quantities of water ice, and during the bombardment, comets were raining down on Earth by the millions. It was a beautiful theory. The water in your veins fell from the farthest edges of the galaxy. Then the evidence came in, and the beautiful theory collapsed. In 2014, the European Space Agency's Rosetta spacecraft completed a 10-year journey across the solar system and rendezvoused with a comet, 67P Churyumov-Gerasimenko. Its onboard instrument sniffed the water vapor rising from the comet's surface and measured something called the deuterium-to-hydrogen ratio. Deuterium is a heavy form of hydrogen, a hydrogen atom carrying an extra neutron. The ratio of regular hydrogen to deuterium in water acts like a chemical fingerprint, identifying where and under what conditions the water formed. The comet's water had a deuterium ratio 3 times higher than Earth's oceans. 3 times. Not a small discrepancy, a fundamental mismatch. If comets like 67P had filled our oceans, the chemistry of Earth's water would be completely different from what it is. The comet theory was not refined or adjusted, it was effectively eliminated as the primary source. The dirty snowballs of the outer solar system brought some water, possibly, but they didn't build the oceans.
Part 4, the real delivery vehicle, wet asteroids. With comets ruled out, attention shifted to a less dramatic but more likely candidate, a specific class of asteroids called carbonaceous chondrites. These are among the oldest objects in the solar system, ancient rocky bodies that have barely changed since the earliest days of planetary formation. They don't look impressive. No ice, no tail, no glowing nucleus, just dark, dull gray rock tumbling silently through space. But inside, they are extraordinary. Carbonaceous chondrites are saturated with hydrated minerals, clays and silicates where water molecules are chemically locked inside the crystal structure of the rock itself. Not liquid water, not ice, water bonded at the molecular level into solid stone. Some of these rocks contain up to 20% water by mass, all of it invisible from the outside, all of it bound into the mineral framework. These asteroids formed in the inner part of the asteroid belt, a region cold enough for some water to survive, but not cold enough to form pure ice. They are, in the most literal sense, wet rocks, and their deuterium ratios are a very close match to Earth's oceans. During the Late Heavy Bombardment, these wet rocks fell on Earth by the trillion. Each impact released an enormous amount of energy, enough heat to flash the water locked in the incoming rock into steam. That steam joined the growing atmosphere, and over millions of years, impact by impact, the atmospheric water vapor built up until something extraordinary happened. The oceans weren't delivered as a flood. They were assembled molecule by molecule, embedded in stone, over millions of years of cosmic bombardment. The most patient delivery in the history of the solar system.
Part 5, the radical theory. The water was always here. But in recent years, a new hypothesis has emerged that challenges the entire delivery model from the ground up.
What if Earth's water didn't come from space at all? What if it was here from the beginning, hidden inside the planet itself? This is the internal degassing hypothesis. It proposes that the dust grains that originally formed Earth were not as dry as the standard model assumed. Even in the hot inner solar system, water molecules could have bonded to the surface of dust particles and been incorporated into the rock as the planet assembled. Not as liquid water, not as ice, but as a chemical component of the mineral structure itself, buried deep in the planet's interior as gravity compressed dust into rock and rock into a world. If this is true, Earth was born already carrying the seeds of its oceans. The water didn't arrive from outside. It was locked inside the mantle under enormous pressure, hundreds of kilometers below the surface, waiting. To test this, scientists needed to recreate the conditions of Earth's deep interior in a laboratory. The tool they used is called a diamond anvil cell. A tiny sample of mineral is placed between the tips of two gem-quality diamonds and compressed to pressures equivalent to hundreds of kilometers underground, while lasers heat the sample to simulate mantle temperatures. The results changed the field. Under extreme pressure, certain minerals don't simply crack or melt. They reorganize at the atomic level into new high-pressure forms. And in these new structures, there are molecular cages with exactly the right dimensions to drop and hold water molecules. Rock, under sufficient pressure, behaves like a sponge. Then came a piece of physical evidence that confirmed the theory. A volcano in Brazil ejected a diamond from the deep mantle, from depths between 400 and 600 kilometers below the surface. Inside the diamond, preserved as a microscopic inclusion, was a speck of blue mineral called ringwoodite. Ringwoodite only forms at those extreme depths. When scientists analyzed it, they found it contained approximately 1.5% water by mass. 1.5% sounds trivial, but the transition zone of Earth's mantle, the region where ringwoodite forms, is an enormous volume of rock. If that entire zone is as water-saturated as the sample in that diamond, the math produces a staggering result. There is a reservoir of water locked inside Earth's mantle equivalent to 3 times the volume of all surface oceans combined. The Pacific, the Atlantic, the Indian, the Arctic, all of them together are the overflow. The real ocean is solid, invisible, buried 400 kilometers below our feet, locked inside blue mineral crystals under pressures we cannot fully imagine. We are not living on a water planet. We are living on the thin, wet surface of a planet that is far, far wetter on the inside.
Part 6. The Great Rains, How the Oceans Reach the Surface. Whether the water came from asteroids, from the deep interior, or from some combination of both, at some point it had to reach the surface, and the mechanism that brought it there was fire. The young Earth was geologically ferocious. Its interior was still hot from formation, supercharged with radioactive decay and residual heat from the original accretion. This heat drove volcanic activity on a scale that has no parallel in the modern world. Millions of vents, fissures, and eruption sites opened across the cooling crust, pumping material from the mantle to the surface. As molten rock rose from the depths and pressure dropped, the water locked inside the rock's mineral structure was released, flashing instantly into steam. Over millions of years, volcanoes were not just erupting lava, they were degassing the planet, pumping trillions of tons of water vapor, carbon dioxide, and nitrogen into the sky. The atmosphere thickened, clouds formed, not the light white clouds of a modern sky, dense, dark, globally connected storm systems pressing down on the surface with pressures hundreds of times greater than today. The greenhouse effect of all that water vapor kept surface temperatures dangerously high. The water was everywhere and nowhere, suspended in the atmosphere above a planet still too hot to receive it. Then the cooling began. Heat radiated into space. The upper atmosphere dropped below a critical threshold. Water vapor molecules, which had been vibrating with thermal energy for millions of years, began to slow. They condensed around particles of volcanic dust. The first clouds thickened. The first raindrops formed. They fell and evaporated before reaching the surface. The ground was too hot. Each drop hit the rock with a hiss and a flash of steam. The rain was real, but the surface refused it. For centuries, perhaps longer, the cycle continued. Phantom rain, falling and vanishing, each drop conducting a microscopic heat exchange with the rock below. But each drop also stole a fraction of heat from the surface on its way out. The rock was losing the battle. Eventually, one drop fell and stayed. After that, the transition was rapid. Once the surface could hold liquid water, the rain accelerated its own cooling effect. Water absorbed heat from the rock, carrying it away,
More rain reached the surface, more cooling. A cascade that once started could not stop. Geological models suggest the rains that followed lasted somewhere between 10,000 and 1 million years, a global deluge with no witness and no pause. Lightning constant across the sky, choked with volcanic gases, rain hot and acidic, laced with dissolved carbon dioxide, falling as weak carbonic acid that attacked the volcanic rock below, dissolving minerals carrying them toward the low points of the landscape. Water followed gravity. Streams became rivers. Rivers found the deepest craters and basins left by ancient impacts. The basins filled, connected, deepened. The lava fields that had dominated the surface went dark and silent as they disappeared beneath rising water, cooling in to pillow the salts on the ocean floor. When the clouds finally thinned and sunlight reached the surface again, it did not illuminate a burned red rock. It illuminated a water world, a single unbroken global ocean covering perhaps 95% of the surface, interrupted only by chains of black volcanic islands still venting smoke into a pale orange-tinged sky. The oceans existed. Life, eventually, would follow.
Part 7. Why water is this strangest substance in the universe. The story of how water arrived on Earth is astonishing. But there's a final layer to this, the properties of water itself. Because if water behaved the way chemistry says it should, none of what followed would have mattered. Water is a molecule, 2 hydrogen atoms bonded to 1 oxygen atom. By its size and molecular weight, it should be a gas at room temperature. Ammonia and methane, molecules with similar mass, are both gases under normal Earth conditions. Water should be too. The oceans should never have stayed liquid. Water survives as a liquid because it cheats. The hydrogen atoms in a water molecule carry a slight positive charge. The oxygen atom carries a slight negative charge. This means that the hydrogen end of one water molecule is attracted to the oxygen end of a neighboring molecule. They bond, weakly, transiently, constantly, in a flickering network of connections called hydrogen bonds. These bonds hold the molecules together in a liquid state far above the temperature at which the math says they should evaporate. Without hydrogen bonding, Earth's oceans would have boiled away into space billions of years ago. Every living thing, which is mostly water, would never have formed. The liquid medium in which chemistry became biology would not have existed. Water bends the rules in one more critical way. When almost any substance cools, it contracts. The molecules slow down, pack tighter, and the solid form is denser than the liquid. Ice should sink. Every physical intuition says ice should sink. It doesn't. As water approaches its freezing point, the hydrogen bonds force the molecules into a rigid hexagonal crystal structure, and that structure takes up more space than the liquid. Ice is less dense than liquid water. It floats. This single property is why complex life exists. If ice sank, winter ice would descend to the ocean floor. Oceans would freeze from the bottom up, turning into solid blocks. The heat from the sun would warm only the surface, unable to reach down and melt the ice building up below. Earth would have experienced runaway glaciation, a frozen planet from which there may have been no return. Because ice floats, it forms an insulating lid on the surface. The water beneath stays liquid. Even in the deepest ice ages, the oceans remained fluid at depth, warm enough, stable enough, protected enough for life to survive and eventually return when the climate warmed. Water didn't just make life possible. Its physics, its hydrogen bonding, its floating ice, its liquid stability across an unusually wide temperature range actively protected life through every catastrophe Earth has endured. There is a glass of water somewhere near you right now, or will be soon. Look at it differently for a moment. The hydrogen atoms in that water were forged in the Big Bang nearly 14 billion years ago, in the first few minutes of the universe's existence. The oxygen atoms were fused inside a massive star that burned for millions of years and then died in a supernova, scattering its contents across interstellar space. Those atoms drifted through the cold dark of a molecular cloud until gravity pulled them into the disk that became our solar system. Some of that water was locked inside asteroids that formed beyond the frost line and rained down on a cooling Earth during the Late Heavy Bombardment. Some of it was squeezed out of the deep mantle by billions of years of volcanic degassing, released from mineral crystals under pressures we can barely reproduce in a laboratory. All of it fell as acid rain on a black volcanic surface, pooled in ancient impact craters, and slowly built up into the global ocean that covered this planet 4 billion years ago. Since then, that water has cycled through the planet endlessly. It has been vapor in the atmosphere of the early Earth. It has been locked as ice in glaciers that crushed entire continents. It has been drunk by creatures that no longer exist. It has evaporated from Jurassic jungles and condensed over Cretaceous seas. It has been pulled into the mantle by subducting tectonic plates and erupted back out through volcanoes on the Pacific Rim. The water in your glass is not new. It is 4.5 billion years old, and it has been everywhere. Every ocean on Earth, every river, every cloud, every cell in every living body, all of it traces back to the same extraordinary chain of events. A dry rock, a cosmic bombardment, a planet that learned to sweat, and a molecule that breaks every rule just enough to make everything possible. Which part of this story surprised you the most? Tell us in the comments below. And if you want to keep going deeper into the questions that science is still working to answer, subscribe. The universe has no shortage of things left to explain.